We got the first problem of the week of the new year. So Alice creates a deck of cards consisting of aces, twos, and threes. Bob creates a deck of cards consisting of anything, aces through kings. The decks are allowed to have repeats, so you could have like multiple seven of hearts, and the suits don't matter. So you have some numbers of aces, twos, threes, four, five, six, up through kings. Alice's aces count as one, while the tens, jacks, queens, and kings and aces of Bob's deck all count as tens. And here is the question. If the expected values of drawing a card from either deck are equal, and Bob's deck has at least one card with a value higher than 4, so he's got something that's a 5, 6, 7, 8, 9, 10, jack, queen, king, or an ace. He's got at least one of those. Then prove that if you were to draw a card from Alice's deck and you were to draw a card from Bob's deck, chances are the one you draw from Alice's deck is actually larger. So that's sort of counterintuitive. Bob's got all the big valued cards, but this restriction that their expected value are the same somehow force Alice's deck to be more powerful. So here's an example. Let's say Alice has 2 aces, 6 twos, 3 or 12 threes. So we calculate the expected value here. There are a total of 20 cards, and 2 out of the 20 are aces, so 2 over 20 times 1. 6 out of the 20 are twos, 6 over 20 times 2. 12 out of the 20 are threes, 3 out of 20 times 3. Add that together, you get an average value of 2.5. If you were to keep drawing cards from Alice's deck over and over and over again, and you were to consider the average value, it would come out to be around 2.5 would be the value. And let's look at Bob's deck. 7 twos, 2 threes, 1 5. If you do the same calculation, you'll wind up with an average value of 2.5. Even though it's got a 5 in there, it only shows up 1 out of 10 times. So over the long haul, your average value out of Bob's deck would also be 2 out of 2.5. But if you were to run these decks against each other, the chances, the ways that Alice's wins is she draws a 3 and Bob draws a 2. And there's 84 ways for that to happen. That's 12 threes times 7 twos. And then the ways for Bob to win, there's several other ways, but these numbers are all smaller. So you could have a 5 versus anything that Alice draws. Or you could have a 3 versus Alice's 2 or ace. Or you could have a 2 versus Alice's ace. And here I've done the counting here, and it turns out there's only 50 ways for Bob to win. 84 ways for Alice to win, 50 ways for Bob to win, even though Bob's the one that's got the 5 in it. So somehow this expected value forces Alice to have the winning deck. And the question is, why is this always true? First person to send me a solution wins the prize.